recorded it yet, and you guys haven't done it yet. For number 4, was it a good idea? Noah Lee. Okay. Was it a good idea? Too many lights. Okay. To just think about top minus bottom or f of x minus g of x. What do you guys think? No? Wasn't it smart to put it in terms of x? Wasn't it all ready to go in terms of x? Because you had 1y equals right here. Some of you might not have realized, but the other y equals is right there. So you could have done, now hold on, wait, do I know what's on top or what's on bottom? No. But I can just throw absolute value and be safe. Now pause. Since I used their defined bounds, I cannot pull the absolute value out unless I check what? Yeah, I didn't find the intersections. I didn't find the bounds, so I'm not sure what's going on in between 0 or 2 until I find the intersections, aka the zeros. And so the zeros would be, when I set that whole expression, which ends up just being x cubed minus 4x equals 0. If you had factored, though, what should you hopefully have found pretty quickly? Pulling out an x squared minus 4 is equal to 0. Yeah, don't you get x plus 2, x minus 2? So aren't my zeros, aren't the zeros of the inside handling absolute value, which are the same thing as the intersections, aren't they just going to be 0 and plus or minus 2? Now, do any of these occur in between 0 and 2? No, not in between. There's no 1, there's no 1/2, there's no 3/4. The negative 2 isn't a problem at all because it's not even involved, and the 0 and 2 are the bounds already. So do I need to split this up any further? No. Yeah, Austin. Yeah, if you got like a 1, you would have to say, oh, okay, 0 to 1, 1 to 2, and then absolute value each piece. 1. Oh, the same thing. Yeah. Going back to the beginning of integration, you guys might want to look at chapter 4a, handling integrals with absolute value. We have to look to split up at any zeros. But since the zeros are the bounds, there's nothing in between. There's no place to split up. So then we can just go ahead and pull out the absolute value. And then integrate. We can just pull out the absolute value and integrate. And when we do integrate, we'd end up with 1/4 x to the 4th minus 1/2 times 4x squared from 0 to 2, absolute value, that whole thing. Which would end up with 2 to the 4th, 16. 16 over 4 is 4 minus 4, 16, 8. Ooh, did I pick the right top and the right bottom? No, but that's okay, because what do I have to save me? So the negative 4 is what I solve for, but that's not what I actually need to write as my answer. It's a positive 4. Dun, 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 dun. What ends up happening is you technically have, I think, this is your curve, something like this. If you had looked at it, it would be a little bit not as nasty. It's even worse. But kiddos, when you solve, Ryan, you just put it under the table next to your period, bud. Thanks. Oh, and Joseph, I didn't see you guys come in. There you go. Thanks, guys. So if you guys look at this between 0 and 2, technically they were just asking for this little portion, so it makes sense that I found a negative the way that I did it, but area between needs to be a positive number, always positive. But you can think top should have been 0. Bottom should have been your y equals x cubed minus 4x. But the math led us there, and it's okay. And with the absolute value, we were saved. Okay, on number 5, what did you guys think, just looking at it, would be the better way to go? Just like initially, what did you think? Initially? Okay, those of you that initially thought in terms of x, good job. Most people initially, like at least the majority of period 6, thought in terms of y. Why would they think that? They saw lots of y's, and they were like, oh, it must be dy. However, if you guys went to go solve to do dy, you don't have to show your work, but just real quick, if you had done that, in order to try to plug in, we would have needed to plug in an f of y and g of y. Well, maybe to come over and do our bounds, because we need our intersections. They haven't defined it for us. So to find our bounds, can we set these equal to each other right now as is? No, because x squared and x are different, right?
We're good.
All right. You guys good? We can't set these equal to each other as is because x and x squared are not equivalent, right? So therefore, we would have had to, in order to go in terms of y, we would have had to get x by itself. And guys, how would we get x by itself? Plus or minus square root. And all of a sudden, we have 1, 2, 3. So if you had thought dy, you pretty quickly, hopefully if you had done it correctly, would have gotten a bit stuck and a bit confused. They just wrote it like that in order to confuse you a bit. If you were to solve for y, aren't those functions nice and neat and ready to go?
Yeah.
If you solve for x, a plus or minus square root, ugh. But if you solve for y, oh, that's not bad. And if we were to come over and do our bounds, that wouldn't be bad either. Setting x squared equal to x plus 2. Remember, get everything to one side with polynomial expressions, right? Get one side equal to 0. Then what? Then we factor x minus 2, x plus 1. They did not tell us the bounds, so we make them. So we go from -1 to 2.
But if we've made the bounds, then basically...
We don't need to worry about, and I'm going to show that right now, but we're not going to need to worry about splitting up any further because we already split up. You could just pick whatever random one you want and then pick the other one. You have to subtract them. Make sure you distribute the subtraction. But are we going to need to stress out about the absolute value and pulling it out? The answer is no, because we would only need to split up the integral if there were any other zeros, any other intersections in between, and there aren't. So we would pull out that absolute value. We would have the integral from -1 to 2 of x squared minus x minus 2. We end up with 1/3 x cubed minus 1/2 x squared minus 2x from -1 to 2. Absolute value, just in case we chose wrong. When you guys plugged in, now this one's going to be a little bit nastier because there's no 0, but oh well, we just do what we got to do. So it's going to end up equaling 2 cubed is 8 over 3 minus 2 squared is 4 over 2 is 2. 2 times 2 is 4. That's f of b. F of a, we have to plug in -1 now, so that'd be -1/3. That's going to be a positive, but times the negative. And then that's going to be that good, huh, Charlotte? Then we have 8/3 plus 1/3, which will be 9/3. We'll get back to that. We have -2 minus 2, which will be -4. Then we have -4 plus 1/2. Well, let me do it this way. So we do it order. -2 plus 1/2 would be -3/3. Tyler, you are so loud. Shush. And then -6. 3 minus 6 is negative. Oh, the absolute values. I think we chose wrong again, but it'll be all right. 3 minus 6 is -3. -3 minus 3/2. I'm just doing mental math. Would be -6/2. Minus 3/2 is -9/2. Absolute value is +9. Anybody get there? 4 and 9/2. Dun 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 dun. Do we even have a picture? No. Could we have gotten a picture? Yes. Turns out that my little x squared was not the top. My x squared was the bottom. But if you think about a parabola, that might make sense why the x squared was on bottom. And the line would have been on top. So then technically, if we wanted it to be all nice and pretty and not need to use our absolute value, we would have had to get a picture first. Top is the blue, bottom is the red, and we would have had to write it in that order. But did the absolute value save us? And the answer is yes. Yep, it did. Double check your antiderivative, and then if that's right, just plugging in went wrong. Yeah, plugging in must have gone wrong.
Will they give us ones that you really can't use absolute value, like intentionally?
No. All right, kiddos, here's a dilemma. If you had been depending on pictures the entire time, if you had been depending on pictures the entire time to get you through, why would you be kind of stuck when it got to number 6? Whew.
There's no picture.
Whew, she's nasty, right? Like you wouldn't be able to, most of you wouldn't be able to do that mental math style, right? You wouldn't be able to do that mental math style. But if you weren't depending on the picture, and you were letting the math lead you, what would you think of naturally doing? Absolute value integrate, but hold on, you can't absolute value integrate until you, figure out some bounds. So maybe the picture is not necessary. So let's just go for the bounds, huh?
Actually, it's kind of nice because there's just y's, like there's no term.
Yeah, Tyler's already seeing once you plug it in, there's no constant term, so maybe we can pull out like a common y, but not until we get everything to one side, get one side equal to 0, right? So I'm going to subtract y squared, which will be y cubed minus 5y squared, and add the y. Pull out a common y, right? Yeah, minus 4 minus 1, yeah? So y equals, ooh, there are 3 of them.
Yeah, so it's just one of those x cubed functions that do that.
Tyler's realizing it's one of those x cubed functions, which might be going like something like this, or it might be going like something like that, or it could be, wait. Do we even know that it crosses at 0, 0? No. Okay. So all we know is it's some sort of cubic-y guy, and it's some sort of parabola, and somehow it hits 1, 2, 3 places. Oh. I just made it up, but it's a cubic-y guy that's messed up, and it's a parabola that goes through and hits in 1, 2, 3 places. Now, imagine this is the right graph. It might not be. Actually, don't even imagine. What do I need to do if I have 3 bounds? Split it. So I'm going to go from 0 to 1. There are 2 different regions that have been closed in. Now, I made up the picture. I'm going to get rid of it for a second because that's not even necessarily right. But I know that I'm going to have to go from 0 to 1, and I'm going to have to go from 1 to 4. Now, do I know exactly who's on the right and who's on the left of this crazy guy? Because it's everything with y's. It'll be one of those dy ones. Do I know who's who? No. But absolute value will save me. Now, could I write the absolute value in just to take it out a second later? Yeah. Or could I just write it out? Why is it legal for me just to write it out and say, no, I'm okay. I don't need to split it up anymore? Are there any intersections in between 0 and 1 that would make me split it up further? No. I'm splitting up at the intersections. I'm splitting up at the zeros. It's okay. So I'm just going to write the, wait, hold on. Didn't we already subtract these 2 when we did the bounds? Can't I kind of skip to the y cubed minus 5y squared plus 4y? Is that okay? For those of you that are like, wait, what? I already subtracted. I did this function minus that function, and I got here. Yeah. If you're finding the bounds. If they give you bounds and you haven't done this work yet, then you would have to still do it. Yeah. And then the other one, same thing. Because I'm just going to subtract the exact same one and say whatever. I don't know who's who, but the absolute value is going to save me. Oh, I need my dy first, huh? Now pause. If this was a calculator problem, could you just throw this whole thing into your calculator? With absolute values and everything? Yeah. But in your calculator, I mean, I guess you could use alpha y when you type in the integral, but couldn't you technically just make everybody x's and the calculator is just going to solve it for whatever variable you put? You could put y's or t's or x's. The calculator won't be confused. It's not going to solve it in terms of x because you already set it up in terms of y. So you can use little x's in your calculator. All the numbers and all the expressions are going to be just fine. Does that kind of make sense? Okay. So then, to that end, we can go pretty quickly because some of you guys in homework, some of them get kind of nasty. If this was an FRQ, wouldn't you technically just have to get numbers plugged in and then 4/2 numbers plugged in and then go? And then box it? But to get numbers plugged in, just a quick reminder, you are going to have to antiderive first, plug in those bounds, then absolute value. You guys can be double checking my antiderivative when I'm talking and writing. It gets really dangerous really fast. 1/4 y to the 4th minus 5/3 y cubed plus 4/2 y squared. Nope, not 0 to 1, 1 to 4. If I plug in 1, I get 1/4 minus 5/3 plus 4/2 is just 2. That'd be f of b minus f of a is 0. Because 0 minus 0 plus 0. Just 0. This one's going to be a bit nastier though, right? 4 to the 4th over 4 would just be 4 cubed, which would be 64. Minus 4 cubed is 64 times 5 is 320. Plus 16 times 2, 32. F of b minus f of a. 1/4 minus 5/3 plus 2. Now some of you are like, wait, you plug in 1, you plug in 1 again, can't they cancel? No, they're stuck in absolute values. I'm not canceling anything out. We have to simplify within the absolute value. Simplify within the absolute value. Make them positive and then put them together. Has anybody already simplified 1/4 minus 5/3 plus 2? Okay, I'm going to 12ths, right? I think I have to. So I have 3/12 minus 20/12. 3/12 minus 20/12 is negative 70/12 plus 24/12, which would be 7/12. Double check that math. You good? Okay. Then over here, I have 64 plus 32, which is going to end up being 96. Yes. 64 plus 32 is 96. 96 take away 2 would be 94. So I put together all the whole numbers. And then I have negative 3/23 plus 5/3. That'd be negative 3/25. And then I have minus 1/4. It just makes it a little bit easier for me to tackle. It's a negative 320 plus 5. Oh, thanks. That'd be negative 315. Good job, David. The nice thing is 3 goes into 315, doesn't it? So 3 goes in, that'd be 105. So that'd be 105. So 94 minus 105 will end up being 11, negative 11. And negative 11 minus 1/4. Negative 11, negative 44. And negative 45/4. 7/12 just made him positive, but he stayed the same. To get 12ths, I could go ahead and make this. He's going to be a positive because of the absolute value. Multiplied by 3 would be 5 and 13, 135/12, which I think would be 142/12, which should be able to reduce, yeah?
Yeah. 71/6.
Nice. So we got there? Good. Good. Now, pause. Do we have a picture? We have no clue. I mean, I kind of gave you a clue. It's a cubic-y one, and probably one, they're all like sideways. We have no picture though, but did the math kind of show us where to go? And we just kind of went. Now, in your notes, there is technically a way to get a picture of this, but the only way to get a picture of this is to switch to a mode from pre-cal called parametric mode. Now, did we need the picture? No. Okay, we didn't need the picture. But just for argument's sake, could you have gotten a picture? And the answer is yes. If you've gone to parametric mode, we're allowed to give equations for x's and y's in par mode, right here. We could have made y the t, and then written an x equation with t's, so it's really like y cubed minus 4y squared plus 3y. So we could actually kind of manipulate it in par mode to get the picture, but the problem is, even though you can see the picture and you can find, oh hey, the parabola is to the right and the cubic's to the left. Oh, now the cubic's to the right and the parabola is to the left. Even though you could have found it, the sad thing is in par mode, you can't even do the intersect feature. So if you can't even do the intersect feature, you would have had to solve it by hand anyway. And if you were solving it by hand, can't we just follow the math and split it up with the bounds and then put absolute values? Split it up, absolute values, let's go. Do we need the picture? No. Can you get it? Technically, yes. All right. Here's where we're going to end today as far as notes. Because if you notice, this is the last thing, and then we'll check. Ooh! Anyway, that's tomorrow. Although it's kind of today, but it's not because you guys didn't bring any fruit. Anyway. Oh. There's some fruit in a couple things. Oh, see? And they're spherical. They're celebratory. Anyway, coming back. I love grapes. Okay, coming back. Kiddos, this is an FRQ. This is a good AP FRQ. I'm going to show you real quick how many parts are there to the actual FRQ. 3. This is all we know how to do so far, but this is coming real soon. And this is coming, well, I guess we could have tried C, but we'll just save C till later. So all we're doing is looking at A. All we're doing is looking at A. I want you guys to look at this, look at the function, and realize something. Realize something, okay? If you look at region R, and you look at this function, are we doing right away dx or dy? Dx, yeah. We're not going to get x alone and get the what. No, we're just, yay, it's a function. Okay, so we're going to do dx first of all. Second of all, what are my bounds? Because they don't tell me bounds, but they show it to me. I know 0 because it's stopped at the y-axis. So x equals 0, but isn't there an earlier x?
Yeah.
Don't you need to use maybe your calculator, calculatrice, calculadora?
I thought you were about to say unit circle too.
No, no. But good eye, good eye. You're like, no. Calculator. This is definitely a calculator problem, which means the bound is going to be a decimal. But is the decimal bound, this 0, is it the answer to area? No, it's just a part of the answer. If it's only a part, if it's only something that we need to get through the process to the answer, am I allowed to round it? No. So what we're going to do, this is AP style. AP style. We're going to say the zeros of f of x at the very beginning of the problem. We're going to find the zeros of f of x. And we're going to call them A and B and C. Okay? We're going to do the zeros of f of x, A and B and C. Now, technically, if you want, you could look ahead to the rest of the problem and see whether B or C is actually necessary. To be honest, they actually are not. So you could have found all the zeros at the very beginning. If you read through the rest of the FRQ, we will never use B or C. We are going to use something over here maybe as to what's going on there. These are going to be kind of our 3 important points. But we could have found all the zeros of f of x, or we could just find the first 0 of f of x, because that's literally all we're going to need. And we're going to call him A. Now, are you guys going to have to use your calculators? The answer is yes. Are you going to need to be in radian mode because this is calculus? The answer is yes. But as soon as you write this down at the beginning of the FRQ, guess what you can use anytime you need it for the rest of the FRQ? When you go to do your integral, you can do from A, which you're going to write as a big long decimal, to 0. And how can you make your calculator do that? Stow it. Stow it. Find the intersection As soon as you have the intersection, visualize it. There's an intersection on the screen, right, of your calculator. You have found it. Or actually, technically, this will be the 0. Just find the 0 of this function. Once you find the 0, it's there. You see the word 0 and answer. Second, quit, stow. Make it A, or make it B, or make it C. But from there on out, you're allowed to write the little letter A and you're bound. And then, guys, for R, who's going to be the top of this region? The function itself. Who's going to be the bottom? Oh, just 0. So it's like the one that we did in class. When you subtract 0, it doesn't really matter because the integral solves for this area under the curve between the horizontal axis. So you're going to throw it in and then finish. So ready, set. As I take off lids and get everything ready up here, you guys solve me this FRQ letter A. Go. Use your calculators. Someone in your group is bound to have one, hopefully. Bound to have one. Austin, go get the gray one from my desk. Okay. Yes. Zach. Yes, go quickly. Make sure everybody knows exactly what you're doing. This stow button is very helpful, very important. This stow button is very helpful and very important. Ooh, these are the mint ones. Go team. Yeah. Yeah, the drawer. Next one down. There you go. Well, I meant the little clear one. The red one. This thing's a work of art, Austin. I'm so impressed. Here, I'm going to do this. Chocolate chip cookies on this side. Chocolate chip cookies on that side. Oreos on this side. Oreos on that side. Pumpkin pie, fruit pie, chocolate pie. Go, go, go. Okay. You did? It is Pi Day. Yeah, you can take a cookie.
1.2 times 10 to the
More than 2.9. 2 point... Isn't it negative?
2.90. No, what? No, she's not negative.
Why not?
Oh, we're talking about that number. Oh, negative 1.373.
Ah, okay. Negative 1 point what?
Oh, that's 373. Intersection point. Sorry, we
Is that right?
talk about the area. Something like that.
Yes, because this is not the answer. We need to use it. So we need to write the full decimal and then just make it a letter and use the letter for the rest of the time. I'm not kidding. Write the whole thing. So then, because I was going to cut something and then I got distracted. Okay, so then when you went ahead and plugged in your function, now kiddos, here's the nice thing. You didn't have to write all that down. They called it f. You can call it f. So you can put f of x minus 0 dx with an absolute value just to be safe, right? Although everything's fine. That's on top, that's on bottom. Our bounds are good, so technically we'd be fine even without the absolute value. But what did you guys get as your final area answer? 2.09 or 90? 3? Okay. Will we ace any part that comes our way?
Yes, we
Having to do with area? I hope so. Okay, here's what we're going to do for the rest of the class. Ready? I'm going to put up the homework for section 6.1 in case you haven't had it. You can work on it a little bit as we enjoy Pi Day. I'm going to have some Pi Day shenanigans stuff playing up here on the screen, but some of you, this is almost 6-7 minutes where you could get any questions answered on your test corrections due on Friday. That might be a good idea too, since you have your group and myself. Okay, I'm going to go ahead and get 3 knives up by the pies. And ladies, you may come first. Ladies, you may come up first. Come on up. Grab whatever you want. But share. The whole point of today is sharing. I think we have a berry pie. Is that what that is, Sam? Ah, a cherry pie, a pumpkin pie, and then Austin's mint chocolate. Ladies. Ladies.
Okay, Misty.
Ladies.
Misty, question. Wait,